بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Mohamed Saeed with you, physics teacher. Today we are going to talk about laws of circular motion and what's meant by circular motion. Okay, before talking about circular motion, we should remember the effect of force. What happens when a force acts upon an object? We didn't say that when a force acts upon an object, the object state should change. The object state means its acceleration. The object should acquire an acceleration. This is Newton's second law. When a force acts upon an object, the object state should change. State means, the object state means if there is an object, a force acts upon this object, so the object should acquire an acceleration. You should know that force and acceleration are always in the same direction. If a force in this direction, so the acceleration also in the same direction. If a force acts upon an object, this object moves in this direction, but the force acts in the opposite direction, so the acceleration also in the same direction of the force. Okay, Newton say that if a force acts upon an object, the object should acquire an acceleration. Acceleration means its speed or its velocity should change. Its velocity should change. The object velocity should change, and velocity means speed or magnitude or direction. Okay, again, Newton say that if a force acts upon an object, the object should acquire an acceleration. Its state should change. If it is at rest, it should move, or if it is moved with a velocity, for example, 100 km/h, its velocity should increase or decreases. Should increase or decrease, which means that the object velocity should change. Velocity means its magnitude in magnitude, which means the object speed should increase or decrease, or direction. For example, if there is a static object and a force acts upon it, this object should move, should acquire an acceleration. Its velocity should change. Also, if an object moves in this direction and a force, for example, brake or friction force acts upon this object, the object speed should decrease. If someone throw a pole, for example, if there is a pole, move in this direction, a pole moves in this direction. The ball doesn't change its direction without an external force. So there must be a player that pushes the ball with his head to change its direction. So the force in this case changes its direction only. So the force, if a force acts upon an object, the object state should change. And this means that the object should acquire an acceleration. And this acceleration means its speed or its direction should change, or both of them. Okay? Okay. If we have three cases when a force acts upon an object. When a force acts upon an object, the first case in the same direction, of movement. What will happen? The second case in the opposite direction. Of movement. The third case in a direction perpendicular. In a direction perpendicular to the direction of movement. What will happen? In the first case, if a force acts upon an object moves in this direction with uniform speed, for example, and an external force acts in the same direction of movement, what will happen? If the direction of the force in the same direction of movement, the object speed will increase. The object acquires a positive acceleration. So when a force acts in the same direction, the object acquires a positive acceleration. Positive acceleration, which means its speed increases without changing its direction. This force, in this case, increases the speed of the moving object. So when a force acts upon an object, the velocity should change. It causes change in velocity, but it changes its magnitude only. Its speed increases without changing its direction. In the second case, when a force acts in the opposite direction of movement, for example, an object moves in this direction with uniform speed, and an external force but acts in the opposite direction. For example, brake or friction force, whatever. A force acts in the opposite direction of movement, so the object acquires an acceleration in the same direction of the force. The object acquires acceleration in the same direction of the force, of the acting force, and this acceleration is called negative acceleration. And this force decreases the speed of the moving object. The object speed decreases, its velocity decreases. In this case, its velocity increases. Okay, our lesson today, which is called laws of circular motion, depends on the third case. What happens if a force acts normally to the direction of movement? What will happen? Okay, if we have a stone, for example, and a thread, and you rotate a stone in circular path. In this case, if the thread is cut, what will happen? The stone will move in this direction, right? So it is the direction of movement, v, its velocity. So the direction of the thread acts toward the center of gravitation. So in this case, the angle between acting force and the direction of movement is perpendicular. So in this case, this force is called centripetal force. Again, if a force acts normally to the direction of movement, this force in this case is called centripetal force. And this force causes what? This force keeps the body moving in circular path with constant speed in magnitude but changeable direction. Again, the condition of centripetal force, this force should act normally to the direction of movement. When a force acts normally to the direction of movement, this force is called centripetal force. And this force causes what? This force keeps the body moving in circular path with constant speed in magnitude. Its velocity doesn't change in magnitude, but changeable direction. It changes only its direction. And instead of moving in this direction, it moves. So it continuously changes its direction from this part to this part. So it also changes the direction of movement towards the center of gravitation. So the centripetal force acts in the same direction of the centripetal acceleration acts in the same direction of centripetal force. So also centripetal force toward the center of gravitation or center of the circular path, and also centripetal acceleration acts in the same direction toward the center of, so it keeps the body moving towards the center instead of moving in this direction. It keeps the body moving in toward the center instead of moving in this direction. It keeps the body moving toward the center, toward the center, toward the center, and so on. So it must be continuous force and continuous centripetal acceleration. Okay, again, the condition of centripetal force. Number one, the centripetal force, or the force is called centripetal when it acts normally to the direction of movement. And this force causes what? This force changes the direction of movement of the moving object from tangent towards the center of the circular path with constant speed, and it just changes its direction. In this case, this force only changes the direction of movement to keep the body moving in circular path. Okay? Okay. So we can define centripetal force. What's meant by centripetal force? It is the force that acts normally. It is the force that acts normally to the direction of movement, and it keeps the body moving in circular path with constant speed but changeable direction. Okay. Now I'm going to talk about some examples in our daily life about centripetal force. any force that acts normally to the direction of movement, this force is called centripetal force. The condition, this force should act normally to the direction of movement. Okay, the first example. Number one, tension force. Tension force. In the previous example, if we have a thread and a stone, for example, or a body, and when you rotate this stone in circular path, the thread acts toward the center of circular path. So there is a tension force acts normally to the direction of movement. This force, which is called tension force in thread, acts towards what? Toward the center of gravitation or center of circular path. Okay, and this body, this stone, when the thread is cut, this stone will move in circular path, in tangent, right? So it is the direction of movement. And the acting force, which is called tension force, acts normally. So in this case, this force, which is called tension force, in this case is called centripetal force, because it acts normally to the direction of movement, and it keeps the body moving in circular path with constant speed and changeable direction. Again, tension force acts normally to the direction of movement, so it's called centripetal force, and it causes the same effect of centripetal force. It makes the body move in circular path with constant speed and changeable direction. It changes its direction from this place toward this place, from this place. So it always acts towards what? It keeps the body to rotate in circular path. It always acts towards the center of gravitation. So FC and also AC, both of them act in the same direction toward the center of circular path, because it keeps the body rotates and كانها بتشده toward the center. يعني بدل مش بعيد، لا تعالى عند السنتر، تعالى عند السنتر. So it's called centripetal force and centripetal acceleration. So if I asked you, the centripetal acceleration acts towards what? In the same direction of movement or in the same direction of centripetal force? We said that always centripetal force and any force and its acceleration always in the same direction. دايما الفورس والاكسلريشن بتاعتهم في اتجاه واحد. يعني force in this direction يبقى acceleration واحد. Force in this direction, so acceleration in the same direction of the force. So acting force and acceleration in the same direction. The centripetal force acts towards the center of gravitation or center of circular path, and also centripetal acceleration acts towards the center of circular path. Okay. So in this case, centripetal force acts as tension force acts as centripetal force. A question: هل دايما is always the tension force acts as centripetal force؟ كان في سؤال جه يعني فيما معناه كان مدينا اختيارات. The force that keep the body moving in circular path ومدينا اختيارات، كان كاتب لي tension force ومدينا اختيارات ثانيه وكاتب لي من ضمن الاختيارات centripetal force. وفي اختيارات ثانيه هنقولها بعدين. طيب the question says that the force that keeps the body moving in circular path او acts to keep the body moving in circular path ومديني tension force وسنتريبتال فورس. فكان في طلبه اتلخبطت كتير لان هو كان مدينا tension force والسنتريبتال ومدينا جرافيتيشن اللي هي برضه ممكن تخلي الجسم. طيب لكن هل tension force always act as centripetal force؟ لا. لو انا ماسك جسم معايا فور اكزامبل ثريد وماسك جسم كده معلقه، في الحاله دي هل التنشن فورس اكت از سنتريبتال فورس؟ سنتريبتال فورس يا جماعه، التنشن فورس عشان تبقى سنتريبتال فورس ذا بادي شود موف ان سيركلر باث، لازم الجسم يكون بيدور، يعني لازم يكون ليه دايركشن، لان الشرط بتاعنا ذا سنتريبتال فورس it is the force that acts normally to the direction of movement, which means the body should be in motion، لازم يكون في حركه. The body is a motion state not in static state. لكن لو انا ماسك جسم كده ومعلقه هنا في تنشن بس هل التنشن دي centripetal force؟ لا، لان الكونديشن it is the force that acts normally to the direction of movement، يعني لازم الجسم يكون بيتحرك والقوه دي عموديه، لازم الشرطين دول. the body the force acts normally to the direction of movement، يبقى لازم يكون في force بتاثر ده perpendicularly to the direction of movement، يعني لازم الجسم يكون متحرك. فهنا طبعا مش دايما التنشن فورس acts as centripetal force، يعني انا زي ما قلت لك لو انا ماسك خيط ومعلق جسمي في ايدي، هنا دلوقتي في تنشن بس هو مش centripetal force، يبقى اللي دايما بتخلي الجسم يدور في circular path السنتريبتال فورس. Another example. Gravitational force. Also, the gravitational force, not all gravitational force act as centripetal force. For example, when an object is at rest on the ground. So in this case, gravitational force is this force acts normally to the direction of movement. The body is at rest. Its velocity equals 0. يعني مش في كل الحالات الجرافيتيشنال فورس بتكون سنتريبتال فورس. تمام؟ يعني انا دلوقتي واقف على الارض في جرافيتيشنال فورس، يبقى دي اسمها سنتريبتال فورس؟ طبعا لا. يبقى الشرط عندنا هو when the body rotates. For example, sun and earth. The earth rotates around the sun, right? And this is the gravitational force. And if the gravitational force is vanished, the earth will move in this direction, in tangent, right? So it is the direction of movement. The earth rotates, and the force, which is called gravitational force, acts normally to the direction of movement. So the condition is found now. This force acts as centripetal force because it acts normally to the direction of movement. So this force causes the same effect of centripetal force. Causes what? This force, gravitational force, which acts as centripetal force, keep the body moving in circular path with constant speed and changeable direction. It only changes its direction, the direction of the earth, from this direction toward the center of the gravitation, from this toward this. So we said that the centripetal acceleration acts toward the center of gravitation. بتخلي الجسم يتحرك يقرب من السنتر، كأنه عايز. عشان كده centripetal force, gravitational force acts as centripetal force, and also the object acquires a centripetal acceleration that acts toward the center of gravitation. Toward the center of what? Of gravitation. Okay. Another example. Number 3, friction force. برضه مش كل الفريكشن فورس acts as centripetal force. لازم الجسم، يعني انا لو ماشي كده في طريق، تمام، straight route with a velocity v, and I push the brake, for example. So friction force, in this case, friction force acts as a centripetal force? No, because the body moves in straight line. But when I move in curved line or curved route, for example, in this case, friction force acts normally to the direction of movement. And friction force acts towards the center of this circular path. So it keeps the body moving in circular path. For example, to understand the effect of friction force، اللي انا عايز اقوله بس ان مش كل الفريكشن فورس برضه سنتريبتال فورس، لازم الجسم يكون في سيركولار باث. يعني لو ماشي في ستريت روت، for example, if I move in straight route and I push the brake, so in this case there is a friction force that decreases the speed of the moving object, decreases my speed or the speed of the moving car. It decreases the speed in magnitude, but it doesn't change the direction of movement. But if the body moves in circular path, for example, two routes, route number 1 and route number 2. Let's suppose that route number 1 contains oil. There is oil in this route. So when I move with my car, or a person moves with a car with a very high speed, so in this part, the car will move in tangent because there is no friction force, right? يعني لو احنا في زيت عندنا موجود والعربيه ماشيه في المكان ده. The car will sweep away from its direction, from its circular path, right? لكن لو انا ماشي هنا مثلا for example when a car moves in this route and there is a friction، هنا في oil so frictionless surface. But in this case when a car moves there is a friction in this case, the car will keep its circular path. What is the difference between these two routes? In this case the car sweep away from its route. العربية هنا خرجت من مسارها. لكن هنا بسبب ان في friction the car keeps its circular path. What is the difference between these two cases? The friction. So we conclude that friction keep the body moving in circular path. صح؟ يبقى القوة دي ساعدت العربية انها تمشي في circular path. مش هو ده اللي بتعمله السنتريبتال فورس؟ So we called friction force in this case as centripetal force because it keeps the body moving in circular path with constant speed and changeable direction. مش هو ده اللي بتعمله السنتريبتال فورس؟ يعني friction force in this case عملت نفس اللي بتعمله السنتريبتال force. It keeps the body moving in circular path with constant speed and changeable direction. It changes its direction from this direction to circular path. So in this case friction force acts as centripetal force because it acts normally to the direction of movement and it keeps the body moving in circular path with constant speed and changeable direction. So designers and engineers بيعملوا طبعا الكيرفد رود بيخلوها تكون خشنه شويه في الملفات. لازم الرود يكون rough surface to perform a friction force that keeps you moving in circular path. بيخلوا الرود يكون يعني rough surface يكون خشن علشان يوفروا لك قوه تساعدك to keep you moving in circular path. تمام؟ Another example about centripetal force. Number 4, horizontal component of reaction. What is the story of this force? هي ليها قصة كده. Horizontal component of reaction. What's meant by reaction first? Then what's meant by horizontal component of reaction? Scientists found that العلماء اكتشفوا when the road is inclined لما يكون الطريق يعني انا ماشي بعربيه اهو، لو انا ماشي بعربيه كده اهو وفي كيرفد باث، يعني انت تخيل كده في الطريق دوت هيلف كده مثلا وهنا هيموف ان كيرفد باث وهنا في فريكشن فورس طريق خشن. لكن لما الطريق يكون مايل كمان the car will moves in a friction او rough surface and inclined. لقوا ان في قوه اضافيه there is an extra force that keep you moving in circular path. ودي بتلاحظوها في الكار ريسرز في السباقات. هتلاقي في الملفات تلاقي الطريق مايل شويه، يعني وانت ماشي في الملفات هتلاقي الطريق مميلينه شويه كده، صح؟ يعني اتفرج عليه سباق هتلاقي في الملفات كيرفد روتس هتلاقي the road is inclined. ليه بقى؟ ايه الفكره؟ هم اكتشفوا ان the inclined route provides you with a force extra force that keeps you moving in circular path. اكتشفوا ان الطريق لما بيميل بيديك قوه اضافيه. يبقى انت معاك فريكشن فورس مثلا بتوفر لك سي مثلا فور اكزامبل 200 نيوتن، يبقى انت معاك في جيبك 200 نيوتن بيساعدوك keeps you moving in circular path، بيساعدوك ان انت تمشي في circular path. وكمان في فورس كمان جديده اضافيه اللي هي بنسميها horizontal component of reaction معاك بتوفر لك مثلا سي 300. يبقى انت دلوقتي زودنا لك القوه اللي بتساعدك تمشي في سيركلر باس and keeps you moving in circular path علشان لا قدر الله ما تخرجش من الطريق في التانجنت في اتجاه التانجنت، وبالتالي keeps you moving in circular path من غير ما تتقلب. يبقى انت دلوقتي وفر لك قوه كمان مع الفريكشن فورس. الموضوع جه منين؟ انت حضرتك لو انت راكب بايسكل او موتور سايكل وبتلاحظ انت في الملفات انت بطريقه لا اراديه بتميل، بتلاقي نفسك بتميل كده وانت ماشي بالبايسكل او في الكيرفد روتس في الملفات في طول الملفات. فالميل ده في حد ذاته بيوفر provides you with extra force that keeps you moving in circular path. provides you with a centripetal force. هو بيوفر لك قوة إضافية، centripetal force إضافية to keep you moving in circular path. طيب العلماء بقى حبوا يشوفوا الفورس دي جت منين؟ يعني الميل دوت الفورس دي يعني جت منين؟ اتوفرت منين؟ نمبر 1 when you move on rough road and curved road انت معاك friction force. طالما the car tires touches the road، طالما الكاوتش العربيه لامس الارض خلاص كده انت معاك friction force that keeps you moving in circular path. بس انت لو ماشي بسرعه كبيره جدا في سباق او حاجه في ملف ممكن الفريكشن فورس is insufficient ما تكونش كافيه. انت معاك فورس بس انت سرعتك دي انت محتاج 500 بس الطريق موفر لك 300 بس، يبقى انت كده عندك في 200 مش معاك. so the car moves in tangent and sweep away from the road. هتتقلب بقى وتخرج بره المسار. فاحنا عايزين نديك قوه اضافيه. لو انت محتاج 500 احنا عايزين نخليك الطريق موفر لك مثلا 600 نيوتن، يبقى انت معاك 600 نيوتن وبالفعل انت محتاج 500 بس مثلا يعني. When the road is inclined by resolving forces the weight acts in this direction. انت لو حطيت حاجه على كتاب مثلا for example قلم مثلا كده ورحت مميل الكتاب، ايه اللي حصل؟ بالظبط when the road is inclined the weight resolved into two forces, this force and this force. Okay, this is called vertical component of weight and this acts as friction force. friction force تتعادل مع يعني هنا في friction force بيمنع القوه دي، يبقى دي القوه دي بسبب الفريكشن فورس. احنا سميناها friction force because it acts normally to the direction of movement. You can imagine that this car هتمشي كده مثلا، يعني العربيه دي هتمشي في الاتجاه ده، يبقى لو انت تخيلت هتبقى جايه كده، يبقى الفورس دي acts normally to the direction of movement. اهو العربيه في اللحظه دي هتمشي كده. ثواني بس عشان تبقى واضحه ليكم. This car moves in this direction, right? And this force acts what? Acts normally. The angle between them is 90. So any force that acts normally to the direction of movement, this force acts as centripetal force. So you have centripetal force. Centripetal force. And this force, the vertical component of weight, this is called vertical component of weight. هي العربية هتبوظ في الأرض، يعني هيحصل sinking كده؟ طبعا لا، يبقى there must be a reaction. Force is called reaction. That is equivalent to the vertical component of weight. Reaction. The force of reaction. Okay, this force, العلماء اكتشفوا ان this force, the reaction, also resolved into two forces. Horizontal component of reaction and vertical component of reaction. Vertical component of reaction is equivalent to the weight. They cancel each other, okay? But this force, the horizontal component, acts toward the center of what? Of circular path, okay? So it also acts in a direction normal. The car moves at this moment in this direction. So the angle between them, can you imagine that? The angle between them is 90. The car moves in this direction and this force and also this force. So we have three forces there. Sorry, two forces. The direction of movement in this direction, we have friction force and we have horizontal component of reaction. If you imagine that, the direction between moving, the direction of movement and friction force 90 degrees, and also between this force which is called horizontal component of reaction and direction of movement also 90 degrees. So we have two forces acting normally to the direction of movement. The first one is called the force of reaction. Sorry, the horizontal component of reaction. And the second one is called friction force. So now you have two forces that keep you moving in circular path. Horizontal component of reaction and friction force. واحد يسالني طب انتوا عرفتوا منين الهوريزونتال كومبوننت؟ احنا ما عرفناش الهوريزونتال كومبوننت، احنا حاولنا نوصل للاكسترا فورس دي جت منين؟ احنا خلاص احنا متفقين ان في فريكشن فورس. There is a friction force that tries to keep you moving in circular path, right? طيب احنا لقينا لما when the root is inclined لقينا بقائك في المسار الدائري بقى افضل، يعني there must be an extra force that keeps you moving in circular path. جت منين الفورس دي؟ قعدنا بقى نحلل، عملنا ريسولفنج للفورسز لغايه لما وصلنا ان في جرافيتيشنال فورس اللي هو ويت and this weight is resolved into two forces. ايه الدليل؟ ما احنا قلنا لو انت مسكت حاجه وحطيت وميلت كده هتلاقي الجسم اتحرك. يعني الويت دوت يبقى الجسم ده هيتزحلق الناحيه دي صح؟ sweep in this direction which means that there must be a force that resulted from this inclination. من الميل دوت نتجت قوه، جت منين؟ من الويت. يبقى الويت حصل له ريسولفنج زي ما احنا مشينا كده، يبقى في هنا horizontal component of weight and vertical component of weight. vertical component of weight الجسم العربيه مش هتدوس في الارض، في قوه شدها مش هتدوس، يبقى لازم يكون according to Newton's third law there must be a force that acts in the opposite direction and equal in magnitude which is called the force of reaction. احنا الرياكشن لحد هنا كده مفيش مشكله، طب احنا لغايه دلوقتي مش عارفين الفورس جت منين اللي خلت الجسم الفورس الاضافيه the extra force that keeps the body moving in circular path when the root is inclined جت منين؟ لما عملنا ريسولفنج للرياكشن لقينا الرياكشن فيه horizontal component of reaction that acts normally to the direction. العربيه دي هتمشي كده تمام، يعني هتمشي في يبقى this force اهو ده الدايركشن بتاع الموفمنت في اللحظه دي، لو يعني الطريق كده لو هي مفيش فورس هتكمل على طول يبقى الدايركشن اوف موفمنت، وادي الهوريزونتال كومبوننت دي انجل بتوين ذيم هميلها بس كاشتو يبقى 90. واحنا وي سيد ذات if a moving object يبقى الشرط الاولاني لازم الجسم يكون ماشي and there is an external force that acts normally to the direction of movement. This force keeps the body moving in circular path and acts as centripetal force. It makes the same effect of centripetal force. It keeps the body moving in circular path with constant speed and changeable direction. The role of designers and engineers to provide you with forces مش فورس واحده، هم عايز يديك اكتر من فورس، اكتر من سورس للسنتريبتال فورس، علشان لو حضرتك ماشي بسرعه كبيره جدا انت معاك فريكشن ومعاك كمان horizontal component of reaction، انت معاك two forces that keep you moving in circular path. اوكي؟ فاحنا عايزين نوفر لك اكبر كم من القوه اللي تساعدك to keep you moving in circular path، وبالتالي نزود السيفتي يبقى انت ماشي في امان. This is the horizontal component of reaction which acts as centripetal force because it acts normally to the direction of movement. So it keeps you moving. This is the direction of movement and it acts normally to the direction of movement. So the condition موجود. The body moves and the force acts normally to the direction of movement. So it keeps the body moving in circular path with constant speed and changeable direction and keep you moving in circular path. بتحافظ عليه. بالاضافه انت معاك you have friction force، يبقى انت دلوقتي معاك two forces friction force and horizontal component of reaction that keep you moving in circular path with constant speed and changeable direction. Another force, number 5, horizontal component of lifting force. Number 5, horizontal component of lifting force. Okay. An airplane engines. This called Bernoulli's effect. الطيارة بتطير ازاي؟ The plane flies. في weight, there is a weight that acts towards the earth, right? The rule of airplane engines to provide a pressure to make the pressure under the wings of the plane is greater than pressure at this side, pressure 1 or pressure 2. P1 is greater than P2. يبقى في pressure هيعمل ايه؟ That provide the plane with a thrust force which is called lifting force. If lifting. Okay? When the plane flies at a certain height without moving upward or downward, this means that the gravitational force at this moment equivalent to lifting force. هو الطيار لما بيحب يخش يمين او شمال يعني بيعمل ايه؟ كل اللي بيعمله يروح مايل الطياره بس كده. يعني عايز يروح الناحيه دي هيميل كده وتلاقيها نفس الموضوع. When the pilot try to move leftward or this side, it inclines the airplane toward this left. Okay. لما الطياره بتميل بقى ايه اللي بيحصل؟ ادي الكار انجن سوري الايروبلين انجن محركات، ادي الويت زي ما هو في نفس الدايركشن، بس هنا الاب ثراست اور ليفتنج فورس ان ذيس دايركشن. المحركات دلوقتي في الدايركشن ده، فلقوا ان وين ذا ايربلين از انكلايند لما بتميل لقوا ان هي هتلف كده، يعني بتروح ناحيه دي لوحدها. اذا there must be a force that resulted from this inclination. يبقى اذا في قوه نتجت من موضوع الميل دوت خلتها تمشي في سيركلر باث. طب القوه دي جت منين؟ اوكي نعمل ريزولفنج للليفتنج فورس. lifting force حصل لها ريزولفنج in this direction which is called horizontal component of lifting force and vertical component of lifting force. يبقى في عندي هنا vertical component of lifting force وهنا في horizontal، دي اللي تهمنا بقى horizontal component of lifting force. This force, which is called vertical component of lifting force, is equivalent to gravitational force. They cancel each other. عشان كده الطياره لما بتلف كده ولا بتطلع ولا بتنزل، لان القوتين اللي هي vertical component of lifting force and gravitational force they equivalent to each other. بس هنا في قوه الناحيه دي ومفيش قوه قصادها. يبقى we have horizontal component of lifting force that acts toward this direction. So the airplane كانت ماشيه كده صح؟ دلوقتي في فورس بالاتجاه ده. متخيلين يا جماعه؟ يعني اهو انا هعملها بس كده عشان يبقى perpendicular. يبقى the angle between the direction of movement and this force which is called horizontal component of lifting force, the angle between them is 90 degrees. So this force acts normally to the direction of movement, so it acts as centripetal force. It keeps the airplane moving in circular path with constant speed and changeable direction. تخلي الطياره تمشي في circular path بسرعه ثابته with constant speed and changeable direction. Okay? Okay. Okay, now we are going to talk about laws of circular motion. Laws of circular motion. Okay. Centripetal force centripetal acceleration and tangential velocity. Okay. I will start with centripetal acceleration, AC. Okay, centripetal acceleration. When a body moves in this radius, moves from place 1 to place number 2, also radius, it covers a certain displacement, right? Say delta L. This triangle is isosceles triangle, okay? And the direction of movement, the body moves in this direction, right? With a velocity, with a tangential velocity called v. And it also moves with the same direction. But by moving, we learned that we can move the vectors from one place to another. Okay, v. We can move this with the same magnitude and same direction. So v in this case equals v. Okay, so we have another triangle. So this force changes the direction of velocity from this direction to this direction. So we have two triangles. The first one R and delta L, right? And the second one V and delta V. Say this is called delta V. So we have a rule that if we have triangle R delta L and V delta V, base over side delta L over R equals delta V over V. Delta L over R equals delta V over V. Base, in one condition, the are two isosceles triangles. Delta L over R equals delta V over V, because by increasing the side length, the base increases, so the ratio is constant. Delta L over R equals delta V over V. Okay, by dividing the two sides over delta time, okay, delta T and delta T, no change. Okay, delta T, dividing this side over delta T, and also dividing this side over delta T. Okay, we learned that delta L over delta T equals what? Delta L over delta T. L is displacement or distance, displacement over time, which is equivalent to V, velocity. Delta V over delta T also, delta V over delta T, equivalent to acceleration. So we can replace delta L over delta T equivalent to V over R equals delta V over delta T equals A over V. So we can say, we can call this acceleration is called centripetal acceleration. So AC equals what? V times V squared over R. So AC equals V squared over R. Okay? So centripetal acceleration, the rule of centripetal acceleration equals V square of the velocity or tangential velocity over radius. You should know that if we have two objects, the first one of M1, say 10 kilograms, and another object M2, say 100 kilograms. AC of this object equals AC of this object, because centripetal acceleration depends only on the velocity. Both of them moves with the same velocity and same radius, and same. So the centripetal acceleration of the first one equals the centripetal acceleration of the second one, because in this case centripetal acceleration changes the direction of movement in this. نفس الموضوع هنا، هغير الجسم دوت من هنا لنفس الدلتا دي، يبقى السنتريبتال فورس الاثنين equivalent. بس ده الجسم اللي هو الماس بتاعته اكبر هيحتاج اف سي اكبر، يعني لازم يكون الخيط بتاعه بقى تخين شويه. يبقى الاف سي هنا تبقى اكبر من هنا. لكن السنتريبتال acceleration in both cases is the same, because they have the same velocity and same radius. Both of them moves in the same circular path. Okay. يبقى احنا ممكن نلخص, we can say that okay, centripetal acceleration AC equals V square over R. Okay, centripetal force, we have learned that force equals MA, right? So centripetal force equals MAC. So FC equals M. AC equals what? Equivalent to V square over R. So centripetal force equals mass of the moving object times its velocity, square of its velocity over its radius. So factors affecting centripetal force, there are 3 factors. Number 1, mass. M1 and M2 moves in the same circular path. By increasing the mass of the moving object, this object requires a greater centripetal force to keep it moving in circular path. So the truck, the possibility of sweeping away the truck from its circular path is greater than sweeping away of small cars. ليه بقى؟ يعني لو في تراك، في هيفي تراك، سياره نقل، احتماليه انها تقلب على في الروتس، في الكيرفد روتس greater than that of smaller cars. ليه؟ Because the heavy truck require greater centripetal force, because by increasing the mass, the required, you should know that the required centripetal force to keep it moving in circular path increases. يعني كل ما الماس بتاعت الجسم اللي ماشي هتزيد، ده معناه ان هو يحتاج قوه centripetal force اكبر to keep it moving in circular path. طبعا في الحاله دي في الهيفي تراك لو الطريق مش موفر له، يعني مثلا الهيفي تراك سي بسرعات اللي هي ماشيه بيها محتاجه وليكن 500 مثلا 500 نيوتن، but the road provide 300 only. الرود الفريكشن فورس بتوفر لك 300 نيوتن، بس انت بسرعتك اللي انت ماشي بيها دي كهيفي تراك يو نيد 500. سو القوه اللي انت محتاجها اقل، القوه اللي انت محتاجها اكبر من المتاحه، انت معاك 300 بس انت بسرعتك دي محتاج 500. عشان كده heavy trucks they should decrease the speed or velocity in curved routes. لازم يقلل السرعه لاقل قدر ممكن. عشان كده تلاقي مثلا الكوشنز اللي هي اليافط التحذيريه، بتلاقي السيارات انها اقل سرعه، يعني سرعتهم بيقول لك السرعه المتاحه مثلا هتلاقي مثلا البرايفت كارز 100 كيلومتر بر اور، هتلاقي تحت خالص الهيفي تراكس هتلاقي مثلا 60 او 50 كيلومتر بر اور ان كيرفد روتس بالذات. ليه؟ لان الماس بتاعتها كبيره، وباي انكريزنج ذا ماس ذا ريكوايرد centripetal force or the centripetal force required to keep this car moving in circular path increases. هي محتاجه قوه كبيره في الحاله دي بسبب الماس بتاعتها الكبيره، فبالتالي والطريق مش موفر لها القوه اللي هي محتاجاها. The second factor is velocity. Centripetal force is directly proportional to v square. You should know that v square ودي الكارثه. v square مش v بس كمان. يعني for example if the v velocity increases 10 f هتبقى كام؟ 100. هيحتاج 100 في الحاله دي. لو الفي بقت مثلا 20 بصوا الاف هتبقى كام؟ 400. بص زادت قد ايه؟ يعني دي زادت 10 بس. بص زادت قد ايه؟ بقت 400. عشان كده the most effective factor on centripetal force، اكتر فاكتور بيأثر على centripetal force واكتر حاجه بنركز عليها في الطرق هي الفي، لان هي دي الوحيده اللي اقدر اتحكم فيها. يعني ماس اوف ذا موفينج اوبجكت، عربيه وماشيه والماس بتاعتها، وانا في الملف هرمي مثلا الحموله بتاعتي ما اقدرش اتحكم، خلاص دي بقت كونستنت. يعني بالنسبه للكار اللي ماشيه دي، والريديوس نفس الموضوع، هو خلاص الطريق اتعمل والريديوس بتاعه قد كذا، فدول بقى كونستنت بالنسبه لكل اتش كار. يبقى الوحيد اللي ممكن اخليك تغيره وانت ماشي في الكيرفد رود هو الفي. عشان كده تلاقي دايما التحذيرات قلل السرعه القصوى كذا في يبقى لازم هو ده الوحيد اللي نقدر نغيره، وده الوحيد اللي الاثر بتاعه كبير جدا. احنا زي ما شفنا الفي كانت 10، ذا ريكوايرد سنتيتال فورس 100، في بقت 20 زائد 10 بس، بص السنتيتال فورس بقت 400. فكارثه. الفي اكتر حاجه بتاثر على السنتيتال فورس، الزياده بتاعتها بتزود ذا ريكوايرد سنتيتال فورس بمقدار كبير جدا. So you should note that you should decrease the centripetal force as you the velocity as you can, as much you can to decrease the required centripetal force عشان تقلل القوه اللي انت هتحتاجها in curved routes. The third factor is the radius. So designers when they design the routes, they make the curved routes with very large radius, because there is an inverse relationship between radius of the curved route and centripetal force. By increasing the radius, the required centripetal force decreases. يعني عايز اقول لك ان كل ما ريديوس يزيد، عشان كده بتلاقي في الطرق السريعه الملفات بتبقى على مسافات كبيره جدا، تلاقي الملف واخد مسافه كبيره جدا. ليه؟ to increase the radius of the curved root. ليه بقى؟ to decrease the required force، عشان نقلل لك القوه اللي انت محتاجها to keep you moving in circular path. هخليك باقل قوه متاحه معاك تمشي في السيركلر بس، من غير ما تبقى سويب اواي، من غير ما تخرج عن الروت. يبقى to keep you moving in circular path we should increase the radius of the curved root to decrease the required centripetal force، عشان نقلل القوه اللي انت هتحتاجها. هخليك محتاج قوه قليله بس to keep you moving in circular path. Okay? Okay, the third law, tangential velocity. You should note that before talking about tangential velocity, centripetal acceleration, there is a centripetal acceleration and linear acceleration. يعني ممكن سؤال يجي لك عشان نفرق بس what is the difference between centripetal acceleration and linear acceleration of an object that moves in circular path. عندي جسم ماشي في circular path، تمام؟ وطبعا في centripetal force وفي centripetal acceleration. centripetal acceleration دي magnitude. For example, AC, we can say that AC equals 2 meters per second square. While in this case, the linear acceleration equals 0. Linear acceleration, because linear acceleration equals what? A equals delta V over delta T equals Vf minus Vi over time. We said that centripetal force, it changes the speed of, it changes the direction of the moving object only. It doesn't change its speed. So the body moves with uniform speed, constant speed. So Vf minus Vi equals 0. No change in speed in magnitude, but the change occurs in the direction only. So the linear acceleration of an object that moves in uniform, the linear acceleration of an object that moves in circular path equals 0, because this force, the centripetal force, it is the force that acts normally to the direction of movement, and it keeps the body moving in circular path with constant speed. So linear acceleration equals 0 and changeable direction. So the object now in this case has centripetal acceleration and it has a magnitude, but its linear acceleration equals 0 because no change occurs in its velocity, in its speed, in the magnitude of speed. Okay? Tangential velocity, when a body moves in circular path with velocity V. Okay? So V equals what? This body moves in circular path. So when it completes one revolution, so it covers displacement equals what? 2 by R, right? It covers complete revolution. And it takes time equals periodic time, which is the time of one revolution, time taken by the moving object to complete one revolution. So in this case, V equals D over T. So V equals 2 by R over T. Okay, this is called tangential velocity. Tangential velocity. Okay.